All right, guys, this is your review for the midterm. Starting with problem number 1, we have 2y times 2y to the 5th power, y cubed times 2v to the 4th power. When you're multiplying these terms together, you want to combine the like values. So see, we have 2 times 2 times 2, so that's 2 to the power of 3, which gives us 8. Then we combine the like variables. When you see this y by itself, remember that's y to the first power. So we have y to the first, y to the fifth. When you're multiplying those exponential expressions, you add the powers. So 1 plus 5 gives us y to the power of 6. Letter v, we have v cubed and v to the 4th power. So we add together 3 plus 4, and that gives us v to the power of 7. This is our answer, 8. V to the 7th power, y to the 6th power. I just listed the letters in alphabetical order. However, if you have your letters in different order, it still would be correct. Make sure that your exponents are the same, that you also have 8 in front. We apply the same rule to the next problem. You have y to the power of negative 7 times y to the power of 9. When you add negative 7 plus 9, you get positive 2. Therefore, our answer is y squared. For number 3, we're solving for w. Negative 4 times that negative 2w plus 6, we got to distribute 4 times, or the negative 4 times negative 2w, that gives us negative 8w. Negative 4 times positive 6 gives us negative 24, and then we just carry over the minus 8w. From there, look, when we combine like terms, 8w minus 8w, those two cancel out. Now on the right side of the equation, we also have to distribute, this time positive 4 times w gives us 4w. 4 times negative 6, that gives us minus 24. When we go to solve this equation, we would add 24 to both sides of the equation, and look, our positive 24 and the negative 24, they cancel each other out. That negative 6, we would add that 6 to both sides, and when we add that 6, we just carried it down right here on the left side of the equation, and the 4w we carried down on the right side of the equation. From there, we would divide both sides by 4. 4 is canceled on the right, and 6, 4, that can be reduced. We can divide both the numerator and the denominator by 2, which we do to simplify, and we get 3/2 as our reduced answer. W equals 3/2. For number 4, we have negative 7y equals negative 14 over 9. You want to make that negative 7y a fraction. And when you have this equal sign between, that becomes a proportion. To solve, you want to cross multiply. We'll multiply the two diagonals together. 14 times 1, that gives us negative 14. Negative 7y times 9, that gives us negative 63. To solve, we would divide both sides of this equation by negative 63, and we get negative over negative. Remember, that becomes a positive, and this can be reduced. Both the numerator and the denominator we can divide by 7. So in lowest terms, we'll get y equals 2/9. And that's us simplifying as much as possible. For number 5, write the equations, so that means we got to have an equal sign for the vertical and horizontal lines. A vertical line is a line that runs up and down. Our horizontal line is a line that runs left to right. So the line that runs left to right, when we're looking at our coordinate plane, we have our x-axis and our y-axis. When we're talking about the graphs, though, the line that runs through the x-axis would have to be a vertical line, right? So when we see this x value here, this x coordinate, this produces a vertical line. When we have a horizontal graph, those horizontal graphs cut through the y-axis, okay? So our horizontal line is produced when the line cuts through the x-axis. Our vertical line is produced when the line cuts through the y-axis. And here we have our x coordinate as -6. So we know that equation that runs through the x-axis at -6. And our y coordinate is -7. So we know our equation that cuts through the y-axis is at -7. But this is the horizontal graph. And this is the vertical graph. All right, so these are the two equations you should write. X equals -6 for the vertical line, and y equals -7 for the horizontal line. For number 6, find the distance between A and B. A is here at -10, B is at -2. So just count that space. Imagine this is a ruler. You're counting the spaces 1, 2, 3, 4, 5, 6, 7, 8. So that distance would be 8 units. For number 7, we're graphing this inequality on a number line. Remember, when you're graphing inequalities, if your inequality symbol is less than or greater than, you should graph with an open circle. And that's what we have here. If you have a less than or equal to symbol or a greater than or equal to symbol, you should graph with a closed circle. In our case, we have a less than symbol, so we're going to be using an open circle right here at -10. We plot that point, open circle, and see how our arrow is pointing to the left. X are its values less than or equal. That's in the direction of negative infinity. Okay, so we're going to shade that graph on the left side of the open circle at -10. For number 8, we're solving this inequality. To solve this inequality, first we want to add 33 to both sides of this inequality. The 33 and the -33 cancel on the left. We carry down our -6w. We carry down here -3 plus 33, we get +30. And then we divide both sides of this inequality by -6. Now there's a little caveat here that we didn't apply. We need to make this adjustment now. Right? Whenever we divide both sides of an inequality by a negative number, we're dividing by a negative number. We're dividing by -6. So whenever you divide both sides of an inequality by a negative number, remember you have to reverse that symbol. So we have to change the symbol from being greater than or equal or greater than just less than. So you switch it. Our -6's cancel on the right side of that inequality. We just carry down W. And then 30 divided by -6, that gives us -5. Now you do want to write your inequalities always from left to right with your variable on the left side. So we need to reverse this order. And because we're reversing the order, we are going to have to switch that inequality symbol back. So W, since -5 is less than W, W is actually going to be greater than. When we switch that symbol, we're changing that order. Imagine yourself reading it backward. You want to change that order and show that that W is greater than -5. Our final answer, we should have W greater than -5. For number 9, a ball is thrown from a height of 35 meters with an initial downward velocity, this is how fast it's moving, of 5 meters per second. The ball's height in meters after 7 seconds is given by this equation. The height is h equals 35 minus 5t minus 5t squared. Since we're asked here, how long does it take for this ball to hit the ground, we want to know when that height is equal to 0. So right here, we substituted 0 for our height. And when we substituted 0 for height, we also changed the order. We just wanted to put it in quadratic form from highest to lowest. So we put our highest power in front, that -5t squared minus the 5t, and then kept that 35 positive as plus 35. Now this becomes quadratic form of an equation, but all of these terms can be factored by 5. So we factored out that GCF of 5, right? And remember, factoring is the same thing as us dividing both those terms, and what's left over after we divide each of those terms we put in parentheses. So the 5's here cancel. We have t squared for our first term. We factored out the 5. Here we have 1t for the 5t because we factored out the 5. And then negative 35 divided by 5, that gives us negative 7. We factored out the 5. T squared plus t minus 7. And we try to factor that, which normally we would be able to factor, but in this case we can't. 7 is a prime number. We can't find two factors of 7 where when we multiply them, we get negative 7, but when we add them, we get positive 1. So therefore, when you have a quadratic that can't be factored, you want to apply the quadratic formula, and that's what we did here. Negative b, our b term, in this case is 1, right? We identify our terms, our b term. Remember our quadratic form, so ax squared plus bx plus c. In our case, our a term right here is 1, our b term is 1, our c term right here is negative 7. So here's our b is equal to 1, our a term is also equal to 1. But the formula is negative b, so that's why we put negative 1 here. Plus or minus b squared, 1 squared is just 1, minus 4ac. So we substituted the values for a, which is 1, the value of c is negative 7, and in the denominator is 2 times a. Our a term is 1. We simplify this, negative 1 we carry down, and here we have, or carried over this way, so underneath we have negative 4 times 1 times negative 7. That gives us, this is a positive 28, but a positive 28 plus this 1 is how we get positive 29. The square root of 29 is 5.385. And then we carry down the negative 1 in front. And we add these two together. Because remember, this plus or minus means something. That means we get two possible solutions. It's negative 1 plus the 5.385 or negative 1 minus. We use the minus symbol, the negative or minus the 5.385 divided by 2. Both are divided by 2. When we simplify, we get the time as 2, a little over 2. This was in seconds, so a little over 2 seconds, or negative 3.19. This one is obsolete, right? There's no such thing as a negative. That's less than 0 time. So the only time factor that would apply, it takes that ball after it's thrown about 2 seconds to hit the ground and have a height of 0. This would be your answer, 2.19. For number 10, find the value of the cubed root of 8. So you can really just plug this into your calculator, the cubed root of 8, and you'll get 2. That's our answer. But let's think about what the cubed root of 8 means. The opposite of cubing a number is to raise a number to the third power. So what you're asking yourself is for that number, what's the value of that number that I raised to the third power to get 8? Okay, and the number you raise to the third power is 2. 2 to the third power gives us 8. So therefore, the cubed root of that 8 is going to be 2. It's that base number that you cube in order to get 8. For number 11, we have 2 over 5 equals 3y minus 2. Now, the first thing you got to do is we will eventually be solving this proportion, but we want to add this 2 to both sides of the equation first. We can't add two numbers together, especially when they're in fraction form, unless they have the same denominator. So we had to actually rewrite that fraction, that 2 over 1, so that it had a common denominator with that 2/5. In order for me to add these two together, I need that 2 over 1. It was just a whole number, but we made it a fraction by putting it over 1. We want that denominator to be 5. So therefore, I had to multiply the denominator by 5. But remember, whatever you multiply the denominator by, you must also multiply the numerator by. So it became positive 10/5. And 10/5 plus the 2/5 is how we got 12/5. Okay? And from there, we cross multiply. That becomes a proportion. 12 times y gives us 12y. 5 times 3 gives us 15, and to solve, we would divide both sides of this equation by 12. Just like before, we want to make sure that our answer is always simplified in its lowest terms. We can simplify 15/12. Both of those numbers can be divided by 3. 15 divided by 3 gives us 5. 12 divided by 3 gives us 4. So y is equal to 5/4. For number 12, the fourth root of u. So just like before, you can just plug this into your calculator. Now we're looking to solve the fourth root of u. We're given the value as 2. So we need to apply the opposite of the fourth root. The opposite of us taking the fourth root is to raise both of these terms to the fourth power. Me raising the fourth root of 4 to the first power just gives me u. That fourth root of this u to the fourth power just gives you u without that radical. And then 2 to the fourth power is 16. This is your answer. For 13, for each relation, decide if we have a function. Now, when you're given values of your x, remember domain is your x, your range is y. When you're given the values of x and y, what you're looking for, you're looking to make sure that all of your x coordinates are different. That's how you know if it's a fraction, or excuse me, a function. You look at your x coordinates, and as long as they are different, then you would say it is a function. And there's only one of these that is a function. That's relationship number 3. Relation number 1, pin with those 2 arrows, that shows you that both of these arrows produce ordered pairs with the same x coordinate. That's pin to 7 and also pin, comma, -6. And then the same thing for each of the for the chair. Because I see 2 of my terms have the same x coordinate, then it's not a function. Here I see the 3 arrows, so that implies that we have 3, 2 as an ordered pair. We have 3, 7 as an ordered pair. Automatically we can stop there because we see 2 of our terms have the same x coordinate, therefore it's not a function. And then for relation 4, we see 2 of our ordered pairs have the same x coordinate, so it's not a function. So not a function, not a function, function, not a function. For 14, suppose this is given. We have this relation that we're calling S with these 4 ordered pairs. We want to define the domain. Remember, that's our x coordinates, and the range, our y coordinates. So we just want to list them. But using set builder notation, we use our open lines x such that, so you should have a vertical line, and then you want to define your rules for x. X is equal to all of our x coordinates. We listed negative or positive 4, -5, and +8. And then we closed it. Set builder notation for the range, we opened, we put y such that using a vertical line, and then we define y. Y is equal to our -7. -7 is repeated. We do not have to write it 2 times, and then 0, close. So here is our domain and range using set builder notation. For 15, we're using this formula for difference quotient, f of x plus h minus f of x over h, where h cannot be equal to 0 for this given function. So we're given f of x. Already we know what to substitute next to that minus sign. Right here next to our minus sign, we just substituted -7x plus 4. We do, however, need to find f of x plus h, and that's the work we showed here. To change f of x to f of x plus h, everywhere our x was originally, we replace it with x plus h. And that's what we wrote up here. -7 times x plus h plus 4. We have to distribute this -7. -7 times x gives us -7x. -7 times h gives us -7h plus 4. And then down we replaced that function for f of x plus h. We replaced -7x minus the 7x plus 4, all divided by h. We simplify here. Now to simplify, look what happens. We have a -7 times a -7. That becomes +7x. The 7x that's positive cancels with the -7x. We have a -7h over h that are left, so we just carried those 2 down. Because the minus and the 4, this becomes a -4. Minus times that 4 becomes a -4, which cancels with the +4. So we're left with the -7 over h. The h is canceled. And so our answer is -7. That's our difference quotient. For 16, We're given f of x is equal to negative 3x minus 3. G of x is equal to negative 4x squared minus 3. We're finding f of 5 and g of 3. So here f of 5, we're replacing 5 everywhere x is in our f function. Okay, so we get negative 3 times 5, that gives us negative 15. Minus 3, we carry down, negative 15 minus 3 gives us negative 18. So f of 5 is negative 18. And now this should be a g. G of 3, we're replacing our g function. Everywhere x is, we're replacing it with 3. Okay, so that gives us negative 4 times 3 squared minus the 3. 3 squared is 9, right? And 9 times that negative 4 gives us negative 36. Minus the 3, we get negative 39. So that g of 3 equals negative 39. For number 17, the graph of this function is shown below. This is our f function, and we want to find f of 0. Now, f of 0 is just function notation for y when our x coordinate is 0. So we're being given the x coordinate, and we're looking to find the value of y when x is 0. So looking at our function, when x is 0, we look down to see where we intersect with our graph. It's right here at this ordered pair. And really, if you just fill in that ordered pair, I know my x is 0. What is my y coordinate? It's negative 2. And that's the answer to our question. Remember, we want to know the y coordinate. So f of 0 is equal to negative 2. For 18, we're graphing this function. This function is in function notation. Remember that f of x is the same thing as y, but it's also given to us in slope-intercept form. So when we're looking to graph line that's in slope-intercept form, we just need to identify our slope and our y-intercept. Remember, the slope is the m value that's in front of x. So negative 1, okay? Although you don't see a number there, that implies negative 1. Our fraction form of negative 1 will be negative 1 over 1. That lets us know that we're moving down on the y-axis 1 space, to the right 1 space on the x-axis. But that's after we get our first point. Remember, our first point comes from the y-intercept. That b term is positive 1. So we start by graphing our line and plotting that y-intercept, which is positive 1. And then we move down 1, right 1 to get the second point, connect those points to create the graph of the line. For 19, we're graphing now a quadratic function. Okay, now to graph a quadratic function, you know you're going to have a parabola, either upright U shape or you'll have an upside down U shape. And this happens whenever a is less than 0. Okay, it's a negative number. But in our case, we see our leading coefficient a is positive, so we should have an upright graph. We just need to find the vertex. That's critical. We need the vertex, and then we want to find 2 points on the graph that are on opposite sides of the vertex. Now to get this vertex, right, to get the vertex, we can use this format here. Our vertex for this g function, to get the x coordinate, we divide negative b by 2a. And what do we mean when we say negative b over 2a? We're going back to that quadratic form. Our negative b, the term that's in front of x. We don't have 1x, so we know that our b is equal to 0. Over 2a, our a term, right here, we see our a term is 2. So our a is 2, our b is 0. When we substitute those values to get our x coordinate right here, negative b over 2a, we have 0 over 2 times 2. 0 divided by anything is equal to 0. So this is our x coordinate, 0. To get the y coordinate, we take that g function and we substitute the value of negative b over 2a. Remember, we just found negative b over 2a to be 0. So we find the value of this function, this g function, when x is 0. So here we're substituting 0 where x is in our g function. We get 2 times 0 squared. That's just 0. 0 times anything is 0. So that y coordinate, remember g function, that's the same thing as y. The y coordinate is going to be negative 6. So we know our vertex is at 0, negative 6. We plot that point, and then we just pick 2 points on opposite sides of that ordered pair. I just chose -2 and +2, and then I created this table, -2 and +2. I substitute my x coordinate for 2. When I put 2 here for my g function, I get 2 times 2 squared, that's 4, times 2, that gives me 8, minus 6, that gives us a y coordinate of 2. That ordered pair is -2, 2, plot that point. The second point on the right side of my vertex, we use +2 as the x coordinate. 2 times 2 squared, that gives us 4, times that 2, that's 8 again, minus 6, so another 2. But +2 for the x, so 2, 2, and then we connect those 3 points to create the graph of that function. And then for 20, this is the last problem. The graph of this quadratic function with a vertex of 1, 0, right here, 1, 0. And this time it's going downward. We want to find the domain and range. Remember, the range is your y coordinates, the domain is your x coordinates. So when I'm looking at my function on the x-axis, I see that this function continues on and on forever in both directions. So there aren't any limitations. My domain could be any value on that x-axis from -infinity to +infinity. Since we're now asked to use interval notation, you should always put parentheses when you're using infinity or -infinity to define your range. And also, when we're looking at the range values, right, this range of where my y coordinates can be, I do see limitations. There aren't any points above that 0 mark. All of my points start here at 0, and then they go down in that direction of -infinity. So your y coordinates, the range values, can start at 0, right? We put a bracket around 0 because we can have a y value that is 0, or any other number that's less than 0. That's in the direction of -infinity. And again, we put parentheses around that to show that interval notation. So here's our domain and our range. We'll stop here.